Happy to have this session with you all today, and thanks, James, for and the Interaction Design Foundation for hosting this. And I will jump right into the material that I have put together. So I am a professor at the University of Michigan, and I teach usually like and enjoy really teaching about XR. So augmented reality, virtual reality, mixed reality. So in the first portion, quickly, I want to go over some of the terms. We usually call this entire space here mixed reality, so MR. And it's really like a fancy term that has been used a lot in. And so you see me with a little bit of audio, but I'll take over here. So you see me sketch out some of the terminology that I'll be using today. Interestingly, I am using actually virtual reality. I'm standing in a kind of like in a virtual painting room. This was done with tilt brush. And then I sketch using these virtual reality controllers. And that allows me to manipulate the virtual reality and sketch out some of these terms. And I'm actually standing in front of a green screen. So this was recorded in 2019, 2020. And I'm just going over some of the terms here. For example, I'm highlighting the relationship between AR, VR, MR, and XR. So virtual reality replaces the reality. I still like to teach it this way. It's usually you're wearing a helmet and you're looking at a computer-generated virtual environment, no real-world view, only virtual content. Augmented reality, and I have various devices. These devices look pretty similar. This is actually an augmented reality headset, the HoloLens 2 that I used also in some of the material that was shared with you to get you excited about this class. Is an augmented reality headset. There you see mostly the real world augmented with virtual content. So it's a real plus virtual composite view. And what is important to realize is that even though we say AR/VR all the time, that the R is actually not the same. So in virtual reality, the R is a synthetic world, a computer generated world. And the R in augmented reality is, in fact, the real world that we augment and enhance. And there's this term mixed reality, and I've done a bit of research on that. It's been used a lot in actually up until recently, and now we use a newer term, or it's just a newer term, I would say, a new popular term, extended reality or XR. And so both of these terms, mixed reality and extended reality, there's some confusion around them. So here, for example, on mixed reality specifically, we did a little bit of literature review, and we also interviewed experts in one of our research papers. And one of the most popular definitions, even though it's not universally agreed upon, is mixed reality in the sense of the reality virtuality continuum. So this is the reality virtuality continuum that at least the academic environment, the academic community is using most of the time. And when I teach classes in this space, it goes from the real world to, let me get a little laser pointer here. It goes from the real environment over all the way over to the virtual environment. So this is the real world, me standing in there. What I'm actually doing is, and you can see this a little bit composition here. What I'm actually doing is I'm in a virtual reality headset, and you see on my TV that we moved a little bit out today, but I'm in the same room, in fact. And you see on the TV what I'm seeing. I'm actually drawing kind of like into this virtual reality space. And then there is this space, this transition space between the real world to the virtual environment. And if we still see mostly the real world, we would say this is called augmented reality. The inverse of augmented reality is a term that's not often used, but it was in 1994, it was clearly established as augmented virtuality. It's actually seeing mostly the virtual world and incorporating elements of the physical world. So it's the inverse of augmented reality. And it's a little bit hard if you think about this scenario where I'm just sketching in there and you see not an avatar, not a reconstruction, but an actual me. But you see mostly the virtual world around me, and we use the green screen to remove basically the real world and composite this. This is somewhere really in the middle of this spectrum, and we call this a mixed reality capture, where you see the real Michael sketching out these terms. So the terms are virtual reality, computer-generated virtual world, augmented reality, the A for augmented is actually an enhanced or an augmented physical world. There is this idea of diminished augmented reality. So if you watch shows that are on the critical side of these technologies, augmented reality can, of course, like most of these technologies, be misused. And it's not only additive, it can also be subtractive, and it can actually remove things from the world around you. We can trick people in both of these modalities. But usually, augmented is understood as a way of enhancing the physical world. Mixed reality, it then includes augmented reality and augmented virtual reality, the two terms that I just previously used. And then in some definitions, virtual reality is not part of mixed reality. But I use throughout the presentation, I will just say augmented/virtual reality, and I may say XR and the X. I usually use it just as a wildcard. So the X here as an umbrella and wildcard for AR VR. So these are the terms. And in the class, I actually want to establish first the status quo a little bit. So what's been going on in the world, and I have a few examples, and yeah. Anyway, we'll establish that, and then I want to talk about why it's actually hard to innovate in this space. And after that, I will share techniques. That's the core portion of the class today. I've been thinking a lot about what techniques could I give you on the way, some that help you with brainstorming, some that may help you really with concrete interactions and figuring out some new solutions. But a lot of the issues that I see my students struggle with innovation in this space is primarily we don't have enough exposure to these technologies. It's good to dream about them, but we need to play with these devices. But then once you play with these devices, you feel really constrained because these devices today are still on the limited side. And so I will share techniques that will help you think without or around some of these technical constraints. And then I want to close with just a few more things I want to give you on the way. You will see throughout the class, I will become increasingly critical because I need to make sure that this innovation is, in fact, innovation that we want. And I will speak about design ethics and also the design impact of your work before we open up for the Q&A. So, status quo. So, here we'll see me playing Beat Saber. Anything about music, but probably turns into a drummer or something. Going down. And in some sense, this is the status quo. This is what most people nowadays do with virtual reality. They do fitness. And as you can see with Michael, it would do him some good if he did a little bit more virtual reality fitness. And you do sweat in the headset, but it's primarily because it's like so close to your head. I didn't get a lot of exercise this way, but it's a lot of fun. So to a lot of people, virtual reality is actually all about gaming, and this idea of using these technologies in work settings is actually it is present, but it's not really established. I'm not sure where you work. Maybe you can share some of your experiences. But the way I see it, in most professional contexts, we play with these technologies. We see whether they could have a space, but most of the time, we'll actually use them for entertainment.
Here, so it's kind of like in front of the TV now. And I
This
can
is
probably
Pokemon
observe
Go.
as well.
You just saw an example of virtual reality with a headset. Now you see an example of augmented reality. Here I was just shooting this, or catching, I would say catching this Pokemon Go. And Pokemon Go was one of those applications, and it's still around. It's still used. It's a game, essentially location-based game that has an AR mode, and then you can actually like catch a Pokemon. And let me just see that we'll go into this AR mode one more time. So when you jump in there, for some reason, this became one of the most popular AR augmented reality applications. So we're still on the gaming side. Of course, we use a lot more augmented reality things in other places, but here you can see how it's augmenting the world, creating a little bit of a play field with some grass. And then at some point, there will be a little Pokemon spawning in my room, and then I can catch it with some interactions. We have also different types of augmented reality displays. So I didn't cover like all these things that I usually teach, but this is a handheld augmented reality display as opposed to head worn like HoloLens. And you see some examples of head-worn augmented reality displays as well. So the status quo is that we actually have a lot of examples already, and many of you are hopefully excited about some of them. We have in entertainment, in shopping, traveling, news are increasingly using augmented reality to enhance and blend more nicely, like what the weather is going to be like, and some really nice 3D effects we see. And then in social media, you probably see a lot of people experiment, and even on just traditional feeds like, let's say, Twitter or X now, you see people post things that have tried out, but then also there are more specific video platforms like Snapchat and TikTok where this is increasingly used. On the productivity side, we have a few startups in this space that have created virtual reality, augmented reality meeting rooms. There is this idea of really exploring how do we represent people, what are appropriate virtual avatars, how much realism is required. And then also, is it enough to put a virtual whiteboard in there, or do we need other things to enhance our productivity? How can we actually make it better? And so while we have all these examples out there, I would say these are still all mostly toy examples. There is not a single application that I know has replaced any professional work. As of course, on the artist side, there's a lot of really, really good artists that can sketch nicely in 3D around them, and we'll see. We've just seen an example earlier where I was sketching out these things. But overall, it is really more like we are like in this phase of transitioning to some of these. You see how you could argue, various universities, for example, have XR initiatives. Various companies probably also internally have XR initiatives. And so we're like getting ready and understanding this space better, but we haven't had this impact of XR yet. So augmented and virtual reality. And then on the tools side,
and basically have access to all the transform tools here, scaling as well. But so this is just digitally. But what I actually want to do is immersive authoring. So I'm actually going to go into AR. So scanning the environment very quickly. That plays.
so on the tools side, we have now tools that we can run on devices like a tablet, and we can design in 3D on a tablet. And we can also go into a mode that is called immersive authoring here, where we can see me place virtual content in the physical world around me. So this is really concurrently designing and testing that augmented reality experience and styling and interacting with it and like trying out different kinds of interaction techniques. I think some of these tools are pretty good for they require not so many technical skills, and they're good for brainstorming and trying out designs. And so we have made a lot of progress on the front of the tools. There's, of course, still the issue, and you will see the Interaction Design Foundation has several courses and classes dedicated to dealing with some of these issues. There's a massive tool landscape. You may have heard of tools like Unreal Engine or Unity. These are both game engines that are now actually really have sophisticated support for augmented and virtual reality development. But there are lots of other tools that I just mentioned briefly. I mentioned Tilt Brush. I mentioned a few others, and I'll show you a few on the next slide. So it's actually really hard as one of the first steps that is hindering innovation a little bit is like really making sense of this massive tool landscape. And then whenever you do a single project, all the projects I've done over the last 10 years in this space, they were all unique. They all required not just Unity. In fact, they used a variety of tools. And so you feel like you're putting this, if you had to describe your process, you would have to zoom out a little bit. And I'll do that a little bit today to talk about the innovation process. And then, of course, within these tools, very quickly, you can get trapped in some of these tools. And so they don't really convert well between each other. And once in Unity, it's harder to go back and iterate and innovate with designers because Unity, frankly, is still a tool that speaks mostly to developers. So the tool landscape looks like this. We have tools that are primarily like interaction design tools like Figma and Vision Sketch, and these all have now inbuilt support for well, inbuilt. They are gearing up with support for AR and VR, but it's primarily on the storyboarding level. We have a bit more sophisticated 3D authoring tools. Bezier, or formerly Basil, is one of the new ones that I've experimented with in my class. and that could be promising over the next few years. These are still mostly desktop and click and play tools. Then we have more specific tools that are really using specific technology. So augmented reality, AR toolkit here, for example, is focused on marker tracking. And so like when you put up a marker, I don't have one here right now, in front of the camera, can we detect this? Do we show virtual content? And then there's lots of tools in that space that really exploit some of the more specific aspects. There is, if you really want to work in this space, there's obviously this need for 3D content. And so there are tools like SketchUp, Blender. There really seems to be a separate class of tools, and you can see in terms of the skills and resources required to operate and create high quality 3D content. I still think these tools are very, very hard to learn and really get good at it. We also, of course, now have generative AI. And so that space, I wonder whether there will be some questions about that later. There's obviously a lot of ways to now generate 3D content from textual or speech descriptions. And so that space is, of course, interesting. But the quality you get is not the same quality that you could produce if you were actually skilled with these tools. And then there is tools like Unity and Unreal Engine that are, I would say, they produce the highest level of fidelity, and they're also the hardest to use. There's an interesting class of tools, and I'll show some examples throughout, which I just showed Reality Composer, for example. These are immersive authoring tools that are basically using virtual reality or augmented reality directly. And so you're in the space and you can design with them. It's a very interesting set of tools, but as you can see, what you really achieve with these tools is a little bit on the limited side. So let's think a bit more about XR experiences and where we can innovate and what we should be thinking about. So we need to think about the environment where our XR experiences take place. We need to think both about the physical and the virtual. We have, like in film, when you do a movie or when you watch a movie, you know there are like actors in there. So for our content, we need to think about the how do we represent the users, and then how do we represent the characters in there that are 3D models or represented by data. And so we actually need to organize them in 3D space. And then we need to think about the interactions. And a lot of people think about just the clicking and tapping and gesture and voice and all these explicit interactions. But there is a lot of implicit interactions where people look, how people move, what they accidentally look at, what they accidentally walk towards, or intentionally. But more implicitly, these are interactions that we need to think about. So there's there's obviously all the content that we need to take care of, but there are like two concepts that I think are very important, context and story. So when we think about context, we need to distinguish a little bit between virtual reality, what happens there. And here you actually design the virtual environment. You are responsible for creating that environment that you will put your user in. And you have to make sure that it fits your virtual reality, fits within whatever reality, the actual reality that people have at home. Most of the time, for me, it started like laying out a little carpet on the floor, making sure that I don't step outside the boundaries and hit anything. Because design right now is really like assuming there's almost nothing physical around the users. And so we don't do a lot to keep users safe. And I think innovation needs to go into that space, really allowing designers to really make it easier to fit these environments, these virtual environments nicely with the physical world. So on the AR side, you design the AR environment, but you do it to blend with the reality. And so you think about this a little bit differently. You are actually designing not just have this little 3D model appear in front of the user. Oftentimes, that's what augmented reality does. There's a little thing appearing in front of the user. We have to make sure it actually fits within that reality of the user. And so our innovation needs to really go beyond just showing little 3D content in front of the user and getting them excited about that. That's the first step, but then really blending it with the real world. And then on the story side, just very quickly to highlight, actually, the best way to tell the story of a virtual reality experience is when you tell it at the intersection, really where there's boundaries. Some of the best experiences I've had were like pressing virtual buttons that mapped onto physical buttons. And so it really was tangible and it was nice. And of course, there are people thinking about designing gloves and whatnot to make haptics a thing in virtual reality. But really, if we just design the story and at this intersection, then we don't need to instrument users with additional things. We obviously need to instrument the environment and map that. But then that is doable in many settings, actually. And so on the AR side, very important for us to consider that we're actually telling the story as the union. So you showing 3D content in front of the user is what you design, and then as a designer, you don't always have control of what the physical environment of the user is like. But ultimately, that's the experience you're designing. That content appears within the user's physical world, and so it needs to map. When I showed that Pokemon Go earlier, it didn't really seem to fit well into my environment. In fact, it was like hovering in front of a TV, and so we don't actually have all this stuff yet. So um, I'm not going to spend too much time on tools and talking about tools today, but there are a few trends. Many of these tools allow us now, these new tools allow us now to tell the story with techniques and methods that are familiar to us. So making the jump into Unity is pretty hard, but like using a tool like Adobe Aero or Apple Reality Composer or even Tilt Brush, some of the things I showed is nowadays relatively easy. Dealing with context by providing abstractions and new software interfaces. So the tools, in fact, allow us more increasingly to really understand the environment around the user. There are specific tools also within Unity like Mars that allow us to design for an eventual context that in which the users might operate their augmented reality interfaces. And you can see I'm becoming already increasingly technical and specific when it comes to really talking about some of these tools. Three more trends are really, it's easier now to create interactive experiences without programming. And these tools, there's an emphasis in some of the recent tools like Bezi, for example, on collaboration. So it feels like a Google Docs with multiple people around and cursors and stuff. And so we can collaborate in ways that we are familiar with from more traditional desktop work and office work around some of the XR content. And so and now finally, we can also bridge devices and design for AR and VR and actually seamlessly switch modalities. So these are some of the trends. So why is it hard? First of all, there are 8 key barriers to entry. I just said the way I just said it now, it sounded like it's so easy, but many of you may already be familiar with these tools and maybe even experts in Unity. So congratulations on that. But if you remember, when you get started, it's actually really difficult to know where to start. There are these 8 key barriers that we found by talking to professional and semi-professional XR creators and also hobbyists. Making use of online resources, concrete design guidance and examples are lacking, and it's difficult to design for some of the unique affordances of XR. And there are more specific issues. One of the issues is actually that there are too many unknowns in development, testing, and debugging. So it's hard for us to always anticipate the devices that users will be using and also understanding all these differences between the devices. Plus, we don't know exactly where they will be using our AR/VR experiences. And as I just explained, we need to design that story for that context. All right. I think if you break it down in terms of like what I think are some of the really the hardest things that make it hard for us to innovate. First of all, we have a lot of material that teaches us to focus on the user. It is the mantra, the motto in many design contexts. But it's actually pretty hard. We don't actually have a lot of AR, VR users that uses on a regular basis, so we can't just study and observe and then we'll know what's better for them. And so we actually have to make this more like this transfer from observing issues in real world settings and then thinking about how AR VR could actually apply here. And you have to have an idea for that. The other thing is that we don't actually have a lot of really popular applications, so mostly entertainment ones that I just showed, but I can't show you a lot of examples that would really solve real issues that have large user bases that are specific to XR. and we actually still have significant device constraints. I often show the HoloLens 2 2019 headset has lots of real cool ideas, like a visor that we can move up, move down, but it has a very, very small field of view. So it doesn't actually really augment the entire environment around me. And so it's like it gives us a preview of what these devices would look like. It's still relatively heavy, even though they balanced it nicely on the head. The self-contained has a battery. I don't have to wear it like with upcoming headsets by Apple, for example, or Magic Leap in the past. And so we are just making it's really hard to make that hardware, that technical progress. And so for us as designers, to design within the constraints is also really, really hard. Plus, we don't actually have all day, everyday use. We often, in my research, I often think about 5 to 10 years out. And so, what will users do and how will they experience things? So, on the focus on the user side, there are design techniques like design thinking, so more like frameworks that help us with innovation. And one of the first things is obviously we teach about empathy and like really creating this empathy with users. But as I just said, you can't just observe the users of XR. You actually, in my research, we often prototype something that gives them a glimpse of what might one day be a thing, and then we can observe and based on a walkthrough and maybe some more qualitative techniques like brainstorming and interviewing, and then we can imagine that future. There are lots of other issues that I often teach about. And basically, at each of the stages here in the design thinking workflow, we have specific challenges with XR. And I'll talk about some of the techniques today. So, for example, working around technical device limitations and finding appropriate tools, which are not always Unity or digital tools. You will see, in fact, I'll share techniques that are focused on low fidelity prototyping. The other main issue is actually us ourselves. The way we as designers, we always think, when I work with a lot of students, we always think we have to invent this whole new thing. Okay, what is going to be the killer app, the thing that changes this for everyone? Everybody is going to use this. And so on the novelty and creativity side, yeah. So don't do that. Don't invent this whole new wheel. Actually think more about how can you amplify the existing. So I would say amplify rather than replace. So I don't have to replace everything we do in the physical world. You will probably never see success with a virtual keyboard. In fact, physical keyboards are still the best way to operate and enter things, even in virtual reality when you're wearing a headset. And so we should think about how that keyboard, for example, could be mapped into the virtual environment so it's more visible to users when they wear a headset. And so rather than trying to replicate it in the virtual reality, think about more like how to blend it into the virtual reality by allowing people, for example, when I look down, I could see the physical keyboard and things like that. And so think about, but then when I look up, I see this amazing virtual content around me and I can perform this advanced work. So think about that. So I'll go through some of the techniques, what are recommended techniques that I have here. So I use a lot of different techniques, and I wanted to bring them in some order and also list them out so that if you wanted to take some notes, this could be helpful for a Q&A later. These are some of the techniques that I'll talk about. So we have like 1, 2, 3, 4, 5, 6. And the sixth one, each of these open up in a new can of worms, but we'll talk about actually on the brainstorming and coming up with ideas. So what could help us there? Thinking about really like what's unique with XR. Like as I just said, don't reinvent the wheel, amplify rather than replace. So where is our unique hook into really making a difference into creating a meaningful AR or VR experience? And so for that, I think we need to understand really what's unique about AR, VR, the affordances specific to these modalities, and then design around them. I'll talk quickly about making it easier and faster to design. There are two things to think about. The threshold that you need to overcome in order to use some of these tools, and then the ceiling that you will often hit with some of these tools very quickly, actually. And so if you have this really advanced idea, so you will have to find a tool that has not too high a learning curve and still allows you to do so, not too low a ceiling. We'll talk about this. talk about prototyping and Wizard of Oz as one of the techniques that most designers are familiar with, but I just want to make sure. And then in various environments, especially in research where I am involved, we often use this techniques for time machining and simulation. Here I don't have a lot of visuals. It's a little bit abstract, but I wanted to give you this idea that you can use, of course, existing technologies to simulate future technologies. So right now, we can't produce AR glasses that users would wear all day, every day long, and we cannot observe how they would really want to interact when they go to a new world, like to a new place in somewhere in the world, and then like what would be good navigation aids for them and stuff. Most devices don't have the capacity right now to render content really well, and so what are ways in which we can use the existing devices, for example, like a HoloLens, and then design around some of the limitations, for example, the small field of view that it has. And then the last thing I'll talk about is we as designers, especially interaction designers, and I'm guilty of this, but many of my students are also guilty of this. We often just think about what we want our users to be able to do, and what are the interaction techniques that enable these, what are the features, blah blah. But we also need to think about what we don't want to happen. And so don't just design for what you want to happen, but also take into account bystanders, passers-by, like people that are visible to these devices and how and what that means. So think a little bit more on the privacy, security, and then also the safety of users. So let's go through these. The idea hexagon is one of my favorite things when it comes to brainstorming. So this is an idea introduced by Professor Ramesh Raska, who is a professor at MIT Media Lab. And like, what is the next idea we could have in this space? And so he talks about a few different ways of extending the existing and finding the next. So extending to the next dimension, really going from an idea right now that we have, what would be the next thing? So for example, we had 3D, I showed you this video earlier where I was using the tablet to design in 3D. And then from there, the next dimension is actually doing immersive authoring, like redoing it in the space. And there's this kind of like concurrent design and testing, and that to me extends the 3D authoring into the next dimension. So that's one example there. Often we fuse things. So we have like one idea could be, okay, we have this idea, and so there's this other thing, but it's not directly related. But what if we actually combined these two things? So for example, on the media and film entertainment side, so if you have watched various Disney shows, The Mandalorian, for example, one of the concepts and techniques and technologies that I got very intrigued with is virtual production. So now so acting is actually not that hard anymore because you don't just stand in front of a green screen like you saw me earlier. In fact, now we can render this entire environment to the actors around, and then they can actually really interact with some of the virtual content. And so that is really a nice fusion that allows people to really get the next idea and actually eases acting as well. I'm not saying that they are not good actors anymore. I'm just saying it got a little easier. Have to use less of your imagination. Sometimes you can be radical, do exactly the opposite of what you think is a good idea. And to be honest, in my interaction design classes, I often start by having, so we teach about good design all the time, but like do explicit exercises where you like try to really design something bad. And that is a cool exercise because then you intentionally try to be bad. And you don't have to be ridiculously bad, but you design the opposite of what you know is good. And in some cases, actually, you may find something interesting and useful. And then there are a few more techniques to expand innovation, and they're like thinking about like, okay, if you have one tool, like given a nail, find all the hammers. Often we design the tool and then we find all the nails, but I like the one here at the bottom, right? When you have a problem, and let's say the problem is your nail, what are all the ways in which you can solve this? And so what are all the hammers out there? And that could be a very interesting way to think about that. So if you're more interested in that, there's interesting resources from Ramesh Raska. But in general, this allows us to think about ideas and expand ideas. Designing for what is unique. So Could do a whole class on this. In fact, I have. But if you think about what's really special and the affordances, so what is unique to these technologies, we can play with the user's perception. And perception is so what you see in an augmented reality headset or in a virtual reality headset is really driven by the multimodality, also using gesture, voice, and speech, and of course, like motion through the environment. And then an important aspect of XR where I think innovation can happen is actually one of the main challenges that designers face is we often say, hey, this is like 3D and we are like human beings. We grew up in a 3D world. Everything is physical. Everything has depth. This is how the world works for us. Spatial, we should be like super familiar with. But turns out it's pretty hard to design using desktop tools. You feel like you're designing a floor plan. I'm not sure how many of you have looked at floor plans. They work very well for architects, but for me, I cannot imagine how big the room will be when I look at the floor plan of my house. And so I really think designing spatially, again, immersive authoring, that is something where it really is unique and there can be a lot of innovation there. And I think we will see more and more tools that really try to blend this immersive authoring with desktop authoring and enable more designers and yeah, make that easier for us. There are interesting ways where AR VR is unique, is how it blends the physical and digital. I talked about context and story. I talked about intersection for VR and designing for the union in AR. And it's exactly at these constraints where I think a lot of interesting things can happen. So designing, thinking about like what happens between the physical and the virtual world. How do we, for example, foster the mapping between them? But also think about like, okay, now we have a user in VR, but then the family member walks in. What does that mean? Should we have technologies like Space Sense, which was just recently added on Quest, so people are more aware? And we have various XR device sensors that are powerful, increasingly powerful and unique. And so designing for these is very important. Making it easier and faster to design. So I want to throw these concepts in here. So we have a design space that you want to design for. We have a tool. Let's say this is a relatively easy to use XR authoring tool. Doesn't have a name right now, but it has two important concepts here are the threshold. So how hard is it to use? Obviously, let's say this is paper. All of us can look at paper, but using paper and really sketching is still pretty hard on paper, but it's relatively accessible. And so these digital tools usually have some kind of threshold. And so you have to learn something before you can operate them. And then these tools often make trade-offs because there's obviously the most sophisticated tools, let's say Unity or Unreal Engine, that have a very high ceiling, but then they also have a higher threshold. High ceiling here means that you can do a lot with these tools. You will not reach the limits too quickly. So you want to have a relatively large room here. So a lot of the innovation in this space, if you're a tool designer, think about how to transition and reach really like increase the ceiling. And they're often okay to actually also then, if you move this along this graph, you would also have a higher threshold. So let's look at Unity. Unity actually has a relatively high threshold here. So that would be here, but also has so a high learning curve, I would say. But then once you're familiar with Unity and the more you learn about a tool like Unity, you can really do a lot. There's still probably a ceiling. There's probably something that you cannot do with Unity where you would actually implement things natively for these devices. But my tools, a lot of my research, and if you're interested in that, you can look at that or like reach out to me, have really explored like, okay, so how do we lower the threshold and what are acceptable ceilings? So we still want to be able to accomplish something that's important, but maybe not everything. In fact, you may have to transition to Unity, but then I often think about like, how do we enable this transition to tools like Unity? And so it's okay to actually lower the threshold because it empowers and enables more designers. And it's also okay to then have a lower ceiling. The other thing to think about is when my students often prototype an experience, they pick a tool like Unity and then they try to do everything in that tool. And so they really want to do this entire MVP, the minimum viable product in this tool. But what I do instead is like, I teach them to think about the tools that are the best for their job. And it may be that you use a concatenation of tools, sometimes even replace things that you have done in two tools with a tool like Unity in the end, but you don't have to do everything in Unity. And I often teach about these prototyping strategies, and I think they break down into three, and these can actually help with innovation as well, especially when you prototype in teams. There is one, the first one here, which is parallel prototyping, to the idea of prototyping the same feature in different tools. It allows you to really see where can you achieve the best feature implementation, but then also like how do these different tools feel. And there's obviously the idea of iterative prototyping that many of us do all the time, which is like prototyping different features in the same tool. So we pick a tool like Unity, we do everything in there, and then we can see where's the ceiling, and so how easy can we actually do everything in there. The last technique that I recommend, but this requires experience, is really understanding that the tool landscape is massive, but that's fine. I'll just learn the appropriate tools. I still start on paper, for example. It's one of the tools. And then I'll divide and conquer. So I'll break down the problem. And my prototype is actually more like a combination of smaller prototypes with these specific tools. One of the things that is very important when it comes to tools is that they all have technical constraints, especially when you then deploy things on devices. So I wanted to talk about these prototyping techniques. There's a lot of like, if you think about how easy and how hard it is, and how on the fidelity side, like how quickly we can move into high fidelity, you will quickly realize that most tools, for example, cross-platform development with Unity, is actually pretty hard, but also you achieve very high fidelity if you spend sufficient time learning these tools. So there is no way around these tools ultimately if you want to be down there. But there is a lot of techniques that we use in interaction design. Many of these were expanded on in previous classes here by the Interaction Design Foundation. It's also something where I'm very active, but I didn't want to repeat all that. Things on paper prototyping, wireframing, body storming, Wizard of Oz, and that's the one that I wanna focus on too here, paper prototyping, Wizard of Oz, because these are tools that allow us to really achieve higher fidelity relatively quickly without making it too hard. I would say video prototyping is still one of the hardest ways to do, and oftentimes it's actually better to use immersive authoring tools or digital authoring tools rather than putting together a complex video. Paper prototyping and testing, something that maybe some of you are familiar with, is an old idea from 1994 here, prototyping for tiny fingers from Mark Rettig. There's the idea that we actually don't have an implemented interface. We actually have a paper interface, and we have a user, we observe them. There is a facilitator that observes the user, and then there's actually a person called computer, in quotes, a wizard, that puts an interface together for the user to experiment with it and try it out. And so we were thinking about, okay, well, how does this translate into the AR VR space? And so one of the things we experimented with was we still wanted to have a wizard, but we also need to be able to quickly compose an interface, and we use techniques here from 360 photos, and we stream that content from whatever is on that template, and we can stream it to a VR user or to an AR user. And the way this looks is, here I have composed a scene, something that you can do relatively easily. This is a forest scene that used to be one of the first VR experiences when you tried out an earlier Google device called Daydream, a virtual reality headset, where you have like a little forest at night, and you can shine at a few animals, and you have some interesting interactions. So if you wanted to prototype that, let's say you're the person who's supposed to come up with this, then you could use a 360 template like this, and then based on that, there would be a facilitator that puts, for example, these animals in front of you and captures this, and then this is what the user would experience. They would see this spatially around them, like at the click of a button. And we could, of course, I'm going to interrupt this here, but we could, of course, have the wizard, the computer, now come in and actually move some of these animals around, and so play with the spatial aspect and potentially also the depth. But we would probably have to replace some of these assets because 360 doesn't have depth, it's not 3D. And so you're designing around the user, but you have a hard time designing things flying towards the user, for example. And so in 360 Theater, this is taking this idea a little further. If you wanted to prototype like a Pokemon Go app, this is how we would normally do it. We would create an interface that is visible only to the wizard. We would create an interface, which is an AR device here that's visible to the user. And the wizard is actually doing some of the interactions. And the user thinks this is actually a working prototype. So let's say we have a Pokemon that's appearing in front of the user and it's moving a little bit and it's rotated. And to the user, it looks like, wow, cool, this is animated and it's like jumping and stuff. But the wizard is actually operating this interface that's not visible to the user, has more controls, and they can move this object around in 3D space. And the user can they don't see the wizard and they don't see what the wizard is doing, but they have this interactive AI experience and can think aloud and give you feedback even before a lot of the stuff is implemented. Okay, two more techniques, and then we'll wrap up very soon already. So imagining future use cases. So I think a lot about two fancy things, simulation and time machine. So one thing to think about the future is using scenario construction. So I've done this in a lot of my research where basically it's a depiction of a future setting and that is anchored in some of the familiar. So for example, if you wanted to design a future AR furniture shopping experience, like IKEA has, for example, one where you can preview furniture in your space. So that's familiar, but people go to the showroom. So how do we bring it to their home? And so you built in, we've done, for example, a depiction of this where they could then imagine, oh, I could do this in my home, but I have that showroom experience, but in my physical environment. So it extrapolates from the familiar, like the showroom experience, but it brings it to the user's home. And so it pushes the boundaries. And so this is work we've done in 2017 or 16, so it's a little bit older. But so scenario construction really is like allowing people to construct these scenarios. You can work with people, with designers or like end users who are interested in design to really construct some of these future scenarios together. Where would I want, if I had a more advanced headset, lighter form factor, better visuals, better tracking, and works outdoors, what are all the things, all the scenarios in which I would like to use this device? It's a very interesting activity. A lot of us in research combine existing hardware. So for example, eye tracking wasn't built into VR headsets for a while. So a lot of us like, and even hand tracking wasn't available. And so a lot of us put like additional sensors on devices or inside for eye tracking. And so we can also use, for example, before we had all these cameras that were like outward facing, we often use complex setups using OptiTrack for motion capture. So that we can get this. What would it be like to have a device like this that could track all this? And so these are existing techniques where we basically instrument the user or the environment to work around some of the device limitations we have right now or we had at the time to imagine the future. Two techniques that I think are very useful, and we often don't think about this. We think about VR and designing AR, and these are not related, but like what is very important to think about is that you can actually simulate future AR experiences, for example, with a really powerful glasses, and you can simulate them in VR. So you can actually have a user in a virtual reality environment see reconstruction or like a setting that feels like the real world, let them put on tiny glasses. And so work with this idea of empathy and kind of like this plays and plausibility illusion so that the user will actually feel like, oh yeah, this could be future glasses. Plus, also use virtual avatars and put some of those glasses on them so they are not the only ones, they're not the awkward ones. And then you can think about in this space what could be cool future realities. And so that's, I think, is very important. And of course now this has become easier with mixed reality mode that we have, for example, on headsets like Quest, where you can just it's a virtual reality headset, but you can actually see the real world in a mode called pass-through. We have color pass-through now with Quest 3 and Quest Pro. And so this becomes now actually, we have very high field of view. I don't know where there's a headset behind me. High field of view, so 120 degrees. The user has about 180, but 120 degrees field of view in virtual reality. And then we can augment that with these video pass-through devices. Okay, last thing, and then I'll open up for Q&A. After all this, it's very important to think about not just the techniques I shared with you, and I ran through them quickly, and you probably want to think about each of them individually and how can you exploit that in your process. Last thing I want to say is don't just design for what you want to happen. And so privacy and safety is really important. So let's say we have a future learning scenario that we had here, and we wanted people to chime in remotely. We actually developed these ideas during COVID-19 pandemic. A lot of students didn't come in anymore. How can we have an interesting learning experience? How could we have an exam and make sure that groups can work individually but don't cheat and stuff? And so we thought about the co-located and the remote experience, and how do we keep this student's daughter safe? Maybe she doesn't need to appear in this experience. And so many of you have probably lived through this a little bit now through COVID, and like doing a lot of work from home and doing a lot of meetings from home. And so these devices capture, of course, a lot of things, and so we want to be selective about what's being captured. And so we, as a first thing, what we did is actually very effective without without formal training in privacy and security, to think about safer interactions by just thinking about all the actors involved and making sure that they are not just users like Alice and Bob, but maybe also adversaries, if you will, like people who might misuse, and in this case is from another group, and so we wouldn't want to have any interactions. Or like Charlie, who's like the instructor here and observing that these students are not cheating. And so thinking about all these characters and not just the users, but the bystanders and the adversaries, and really thinking about that. And so we developed like character-driven analysis tools that actually, as users, it's like a storyboarding tool that we just presented this year at a conference. But as users design this remote virtual interaction with this avatar, this and they never designed to have a child in the room or something. This, our tool would insert some of these characters, bystanders, or even evil people like the environment manipulator who changes things in the physical environment, that could actually be attacks, security and safety attacks on the user. And so we've been developing a few of these like evil guys here, but in a playful and in a non-formal, not so much theory required on the privacy and security. In the privacy and security domain, this is called threat modeling. And so you really bring some of these characters in. You're somebody who overhears things you say to a device, somebody who injects gestures like the HoloLens, for example. I could just hold my hand in front of a user and that would interact with the device, because we don't have authentication, we don't actually have fingerprinting. And so so these people would be inserted into your storyboard, and that gets you to really think about some of the issues. So I want to close with two important things, and then we have then we have the Q&A. So design ethics. Overall, what else to think about? Like, from what's the most effective and efficient design of your solution, which is a lot of the interaction techniques that we use in our everyday life, and as we innovate in this space, we should also be thinking about, like, did I just create a weapon? In fact, this was one of the things that was said to me for one of my research projects, and almost created some issues when I was about to become a professor at the University of Michigan. That things could be misused. It wasn't that bad. I make it a little bit harder. Sound a bit worse, but like things could be misused, and then you, of course. So Pokemon Go, you can look it up. How many people actually have died playing Pokemon Go, and you'll be astonished that there are actually several deaths reported. That not all of them seem directly related to Pokemon Go, but I'm sure the designers didn't intend for this to happen. But you need to think about, okay, when you produce a tool, gameful, people go into various locations in the physical world. What are actually all the locations they go to? Are those dangerous? Should they go at night to a park just to catch this Pokemon? And so how could it be also misused? Could I attack Pokemon Go, send people to, could I be the CIA and assassinate people that way? Anyway, so you need to think about some of these experiences. And the most important thing as designers is we need to build autonomy into our designs. We need to be transparent to users. Autonomy allowing users to take control at every time. Transparent so that they understand what are we doing with the data, with the gestures, with this voice commands, and then also building considerations of safety into these tools. On the safety side, we don't have a lot of legislation or regulation, so we have to just use our moral design compass for now But we will also see the government and various institutions will, for example, at Michigan, we stipulate certain things before we bring AR VR tools into teaching, and so they will be tested. But I think it's up to us as designers. We don't want to design in the most evil way we can, and then see where it hits, where it clashes, which is what some of the companies do in this space at the moment, just to push the boundaries for legislation. And then last note, whatever you design, and I hope you have some cool innovation in this space and hope that some of these techniques are useful, think about what happens before the user uses your XR experience. So is there something that could help set expectations? Should there be, my students often translate this to onboarding screens, but I just mean really, should the user be in a quiet place? What should be their mindset before they use this AR VR experience? Consider that you have this responsibility designing these experiences, augmenting the user's perception of the physical world, of users around them. So think about what happens before you do this, and how do you get them into this mindset? For example, into a mindset where they understand for the next few minutes, I'm going to suspend my disbelief. I'm going to be fully engaged. I'm going to go to Mars or the International Space Station. But I will remember that I'm actually in my home, in a safe place. And if something bad happens in that experience, I can always recover because I am safe. Then balancing realism and comfort and safety during the experience. And what we don't see a lot, but I think we will see increasingly, especially with XR experiences that trick our senses more, there will be an after phase, a debrief, that helps users transition back into reality. So we don't want to create experiences that capture the attention of our coworkers, of our children, to the extent that it's hard for them to tell the difference between what's happening in the real world and what's happening in the virtual world. And so we need to design these experiences with this critical eye, so that what the design allows users to transition safely back into reality and realize this is just a virtual experience. So there were several references throughout the presentation today at the bottom. Most of these, at the bottom of the slides, most of these refer to papers that I have published in this space. You can find them freely available on some of my websites, but you can always reach out. I know that the way we publish in research, not everything is open access, and so I'm happy to share any of the materials as linked here or cited here. And so this was the How to Innovate with XR, and I'm gonna move to James, who will do a little bit of Q&A with us.
If you were say you were hiring a designer to work on an XR project, what would you be looking for in a portfolio?
Okay, so there is, of course, I'm not going to say, okay, like, oh, how much time have they spent with Unity and stuff. Maybe in the past, it used to be that I was looking for these technical skills primarily. Can they work with these technologies? But in my more recent approaches, I really think more holistically about this. So, for example, do they care about design ethics? Do they have a training in privacy and security? Do they care about accessibility? So do they bring a more holistic picture to the table? So in portfolios, if I were to apply for a job, I would not just like, oh, I've done this little AR app and I've done this little VR project, but I would make sure how it connects to the users. And so who was this designed for? And so one of my projects that I would personally lead with, if I were to apply for a job, is probably this inclusive gym that I've created. It was a smaller project for me. It's not in my main research portfolio, but it allows children in wheelchairs to exercise and play games with each other. And actually, from an AR perspective, it's not particularly technically challenging or hard, but at least it would demonstrate how I think about this space and what kinds of AR and VR solutions I want to create where I see my responsibility. So short answer is probably be good with some of these tools, but I don't think it's good enough anymore. We need to be really thinking about the holistic and the big picture here.
Any advice on the ideal way to determine the scale and position of design elements like buttons and text in XR design?
Yeah. So here's a little thing. Actually, scale is really hard. Often, even when you design on paper and then you bring it into the headset with some of the techniques. But even when you design on your desktop and then you press the play button and then you go into the headset. So this is a number one issue. One of the things I often do is like, and Unity, for example, doesn't do this, and most tools don't do this. SketchUp does this. They show you the height of the average height of a person. So 1.6 meters, for example, is what our headset thinks is the starting height. And so designing against this height, and then also designing like I put objects of a specific size. So for example, 1 meter by 1 meter, and I also put like temporary like placeholder objects in the scene at various distances. So I often design an experience laying it out in a foreground layer, in a midground layer, and a background layer. And I place them at distances that are not too far away from the user, between 1 and 3 meters. And so they shouldn't be too close because most headsets will clip at 80 centimeters. Anyway, so I put in all these little helpers. And I think my students have had good success by using some of these placeholder helpers, and then overall they develop a better intuition. You would say these are all physical units, so we should all know, but actually, like I don't want to always jump into headset to confirm, and so I use these little helpers as I design in 3D. This is probably the most practical tip I can share.
What is your typical design process for an XR experience in terms of tools, software, and hardware, and convergent and divergent thinking?
So I do. So my background was actually not in game development. So I have used a lot of web-based tools in the past, and for some reason that stayed with me. So I'm most familiar with some of these web-based tools. But that's on the digital side. I do start with sketching on paper. I share various templates in my classes. There are lots of cool templates out there to design spatially around the user, to get first rough sketches and then higher quality sketches. I obviously do a lot of like interviews and talking with potential users. And so I often talk to domain experts, understand their process, and see where I can innovate. So this is on the brainstorming, need finding, a little bit prototyping side. And then on the more specific tools, still on the prototyping side, there is a massive landscape with tools that like ShapesXR or Bezier or like many of the tools I mentioned. But ultimately, it'll go into a tool like Unity or Unreal Engine. But that's the last step, not the first thing we'll play with. Where we can actually then deploy it at scale in, for example, in classroom settings. Or like it also gives me more confidence when I give demos. When I demo my prototypes, for example, during my year at Meta, there were a lot of little hiccups here and there, and it can be quite frustrating. When I use some of the let's say the more prototyping tools, and so sometimes I then made this jump into really like my perspective has also changed from thinking about prototyping and really creating a demo. That's like almost like creating a product. A prototype is there for the designer to think through the space and get the idea. And often we teach interaction design, it ends with a prototype and then we hand it up to developer. But I have started to do this extra step to really, because I have the technical skills to really then implement things in a tool like Unity, and then create a more sophisticated demo that I also feel comfortable at demoing. Still, these things still break all the time. Ultimately, involving users is the goal throughout the process, and especially at the end. So I design a lot of user studies, and these are not just usability evaluations. Oftentimes, to be honest, it's the last thing we care about. We ask the more interesting questions on the like, how do you feel towards this experience on the empathy side? Does it create a feeling of presence? For example, do you feel like you're in this virtual environment now? How does it trick your senses? Yeah, so I have more on this that I often do these process-oriented talks, and I also have more material to share. There are, of course, online classes I teach that really go through the process step by step.
In your experience, for what kind of applications have you noticed a limitation of the XR interface when compared to our current 2D apps?
Yeah, so most of these immersive authoring tools that where you, like on a tablet, for example, you can then move things around on a tablet and then you see how they are rendered in the physical space. And then very quickly you will start to really prototype some interactions. You're like, okay, what if the user now walks towards it? Could this be animated and spinning and things like that? And so it actually, these animation things and these interactive things are really not so much fun to prototype while you're standing in the room and stuff. And so I think most tools right now don't achieve a good workflow, I would say. They find their place somewhere in the workflow, but within a tool, Unreal Engine is, for example, one that I think is pretty good on the VR side. So you can do a lot of desktop authoring in VR, but then at any time you can just jump into the headset, have even some of the same windows appear in virtual reality, do some tweaking, and then take off the headset again, and then go back and do those tasks that are really good on the desktop, where you can be very efficient. So I think the tools should support this flexibility in workflow, and I feel very constrained if they don't, because I don't want to click through 1,000 3D windows just to get something animated. And so I very quickly hit the ceiling there. And then, of course, any kind of like, it depends what your mindset is and how you think about things, whether you need gesture tracking, object recognition, and these kinds of things. These are often not really built into these prototyping tools. You would need to add additional tools like Media Pipe or some of the AI tools we have now. And so I think that gap is also like that the AI techniques, they're like up and coming, and somebody asked about those as well. But we all have to figure out our workflow now and how they should fit in, but we don't actually have a lot of tools that really blend these nicely. So I would suspect in the next few years, you will see there will be a command to generate a 3D object that you describe, and it'll be there. And then you say, I want to animate left, right, blah, blah. And so we already see some examples of this in research. And I think this will help us make more progress and innovate faster.
I think you answered Jian Hao's question as well, which was how can we combine AR with XR together for better design now? But it sounds like that's an upcoming thing. Would that be correct?
I think you will see more of it. I will say that this has been an extremely difficult semester for me coming back from sabbatical, and then all my students play with generative AI. And when I say, and I needed to figure out, like, well, as an instructor, like, what's my perspective on this, and should I forbid this in my classroom? But of course I don't, because I know that my future little designers, they want to be fast, they want to move at the speed of thought, which is very, very important. And so generative AI has a role. I would just advise that if you're a beginning designer, to still take this extra step and learn how to do some of this manually. It just gives you a better theoretical foundation. But once you can write, for example, let's say you know how to write a research paper, I think it's okay to use, I mean, probably not, I'm not saying it's okay to generate a paper with generative AI. What I'm saying is, then I would be more comfortable using some of these tools as part of your process because you are already experienced. And so that's why I think I would still like to really get better at 3D modeling myself. And I don't want to just offload it to an AI, but I think since I never had the time to really get good at it, it might be one of those things where it would help my workflow. And yeah, there's a last thing to think about, like, which is authorship. When it comes to generative AI, are you still the designer? And so I would do as much as possible so that I still feel like this is my design. It's not just the prompt engineering. I didn't just know how to ask the right question, but I also tweaked it and then did these improvements. And so then I would feel better. I cannot imagine delivering a generated thing to a client because I would feel like I'm lying because I didn't actually create this myself. But assistance in the tedious steps, I think that is something that I would appreciate.
What XR design guidelines or standards would you recommend to follow as for now?
Yeah, usually when I teach about design guidelines, I give a long 20 minutes, like why it's hard and why it's so sad and why we don't have a lot of good guidelines and blah, blah. And then I was thinking, so what are actually guidelines? So I made up my own guidelines over the past. They fall into a do and don'ts. So what you shouldn't do. And some of them, for example, include when we create a mixed reality learning environment or like a virtual conference room environment. I've been to a lot of virtual conferences now. We just replicate all the issues in the physical world. So why do we have stairs in virtual reality? So I talk about this, and so in the absence of guidelines by vendors, I was making them up based on my research and based on my experience. And so I have specific materials for that I'm also happy to share. But right now, what I also tell my students is like, read about the human interface guidelines by Apple, and Google also has some on material design, but then also thinking more about AR and VR. And in fact, they have cool tools that allow you to experience these guidelines in AR. So like you're running a little app, it's Google AR Elements, and you can see these guidelines while you're actually trying an AR experience on your phone. And so these vendors, obviously, I think the first step is to be familiar with the vendors and what guidelines they have, and they keep publishing them and updating them. And then I think the second set of guidelines should still be based on your own experience. Like, so for example, you can complain about the small field of view of a HoloLens all you want, but there are techniques to, for example, we used ideas of having virtual windows in one of our mixed reality experiences. Windows are they feel natural, but they feel like a constrained viewport, but they are just small enough to be rendered most of the time in a headset like this. And so I think if you can innovate at some of the limitations and the constraints of these tools, there are also some interesting guidelines there. So last guideline is that I think is an actual guideline that we should all keep in mind, goes back to my design ethics and easing a user into an AI. Right now, you download an app and it opens and bam, everything is around you. And so like we need to, one of the important guidelines is to really help users transition into this VR experience and transition between different scenes so that don't experience motion sickness, they're not like confused. And so a lot of the traditional interaction design guidelines still apply, like keep it simple, keep users safe. My problem with those guidelines is though that they are not actionable. So I often, like, they are good principles, rule of thumbs, but I would refer to more specific vendor guidelines that I think are improving. So most of these questions I have a lot to say, so sorry, James, long answer.
No problem at all. It's all great stuff. And I'm going to be thinking about why there's stairs in VR for a while after this. That's a great way to make you think differently about it.
Well, they're not good from an accessibility perspective, but they, of course, they remind us of the physical, and so they ease the transition. And so it's often that you're designing at these trade-offs. But yes.
Can you talk about accessibility in the XR space? So how it differs from 2D design and how do you design for accessibility in XR?
So when I think about accessibility in this space, so I really, first of all, accessibility here as the technical term, so designing like universal design, designing for people with all kinds of abilities, physical, cognitive, etc. So in that space, the first thing I would say, most XR tools are actually not accessible. They're predominantly visual. They are not multimodal. They are hard to operate if you have physical constraints with motion, etc. So a lot of research is needed in this space so that these tools themselves to enable more people with certain impairments so that they can also be active, better empowered. So the first thing I say. The next thing I say is, as an end user, when you are actually in an XR experience, a lot of designers, we make the mistake that we design not for this multimodality. So we have maybe one gesture or a set of gestures that we like, but then we don't think about speech because we feel like, oh, voice, nobody would ever use this. I don't like to use it. And so, but we actually need to design this flexibility into our experiences so that somebody could actually achieve the same command with voice if they are, for example, have a harder time enacting certain gestures. And so the last thing in this space is really making AR VR accessible, and there's like cool research by Microsoft Research, for example, where you could have like a white cane, like if you're a blind user, but then in hand, like you could actually touch the physical world and have a VR experience with a white cane, it's a cane troller. Or there are tools like Seeing VR that allow us to simulate, for example, certain visual impairments. As able-bodied designers, we can get a glimpse of what it might feel like to see our VR content under certain visual impairments and conditions. So last thing I'll say is, I think AR VR technologies have really a tremendous opportunity to enable and empower people. So I also think that current vendors like Microsoft and Meta, they are all sad that they can't produce the displays yet, but they realize now that we can do a lot with audio, and just putting cameras on people's heads as an assistive device is extremely powerful. Meta, for example, just announced that you can now speak to it and use AI, and the AI can process what you see, and it can be helpful. And so we will see hopefully more of these in the future. And I think with an assistive spin, I think it'll be well accepted. But if we all walk around with our AIs on our heads and we capture everything and see everything, it will also create lots of challenges in professional settings, challenges for social acceptance. And so, but in the accessibility space, I think there is actually really a good opportunity. And yeah, and I would talk about situated impairments as well. So not just designing for permanently disabled, but design, for example, wearing glasses while you're driving in the future is an important scenario, and you have lots of mental constraints and physical constraints because you're supposed to be driving, unless maybe we'll have autonomous vehicles really working in the future. So it's interesting to design some around some of these situational impairments as well. And so accessibility, very important topic. A lot of innovation should go there. And so thank you for that question.
How much should we be focusing on web VR?
Yeah, web VR. So I still use it and teach it. It's web VR. So basically, the main benefit is it's very easy to share the content with other people. They still need a headset, or they can open it on a desktop computer in 3D. But it's really just like we now share things on the web. I'm sending you a link, and then you run it on your headset, and then you see it on a browser, and it's easy to network these experiences. So then I could see a representation, know where you are, and so I am a really big fan of still the WebXR. I also think that when it comes to the web, there is at least still this ambition to create a safe space that is kind of like not a monopoly to a single vendor like Meta or Google, or it's like the space where we all come together. And so we have some regulation. We have a W3C consortium that tries to regulate and innovate. And so I still think some of my friends working at Mozilla, and Mozilla has been a supporter of some of my work as well. I like that they are thinking about this, creating this open ecosystem, and I think it's a very good place for innovation. All that said, I know that it's a relatively slow platform. It is hard to distribute content that way. We have, as designers, we have to put in a lot of extra effort to get our models to render, be smaller, be distributed faster. So a lot of technical additional overhead. But I think it's worth it from the perspective that it's easier to share, and maybe also would help more with open source and really so that we can learn better from some of these experiences. In my own work, I'm a big proponent of WebXR, but when I go to various companies within this professional context, it's not as popular as a set of tools. That's both sad, but that's also the reality. And so I would say, as a designer, it's a bonus if you are experienced with WebXR and WebVR. It's not a requirement. And if it's the only thing you can do, it will put you in a niche that will be hard from a professional employment perspective, at least at the moment, hopefully better in the future.
Amazing. Well, thank you so much, Michael. This has been an incredibly insightful presentation on XR. So yeah, thank you so much. And thank you from everyone who joined us.
Thanks, everyone. It's good to meet you.
Thank you, everyone, again. Thank you, Michael. And we'll see you all next time.